Now we have seen how to work with an EKS cluster that has node groups attached to it. So basically we have run our application on an EC2 instance managed by the node group that is then connected to the cluster. As an alternative to node groups and EC2 instances, we can also work with Fargates. And Fargate, as you have already learned, is a serverless way of deploying containers and creating pods in our cluster. So that means we're not going to create any EC2 instances in our AWS account, but rather we're going to let AWS worry about and create these compute resources, virtual machines, be it EC2 or some other types of virtual machines, on AWS account. So just like the EKS cluster is managed, created, configured on AWS own account, managed by AWS, so we don't see any resources created in our AWS account, the same way the virtual machines that Fargate provisions for us to run the container and the pods will also run in AWS managed account. So we're not going to see anything here. One important difference between Fargate and EC2 is that when we create pods using Fargate, Fargate will actually provision its own virtual machines for each pod. So basically, we're going to have as many virtual machines as we have the pods. On EC2 instance, however, we can have multiple pods running. And this difference or this characteristic of Fargate actually has some limitations for what we can deploy through Fargate. So for example, deploying stateful applications or daemon sets that are basically applications that will run on every node are not going to be possible through Fargate. So you should be aware of these limitations when using Fargate as your worker nodes. So with that said, let's actually go ahead and create a Fargate profile and attach it to our EKS cluster. And then let's deploy a pod using Fargate. And we can actually create a Fargate profile in addition to node groups. So we can have both EC2 instances in a node group and Fargate profiles, both connected to the same cluster. So before we create Fargate profile, we need to create a role that we're going to give Fargate. So just like we did for all these different steps till now, we created a separate role for the EKS cluster because EKS service needs certain permissions to work with our account resources and services. The same way we created a new role so that EC2 instances, the worker nodes, can do stuff to other AWS services. So the same way we're going to need to create a role for Fargate. So basically, when our cluster creates pods on AWS Fargate, the pods or kubelet on these virtual machines that Fargate will provision for us will need to also make calls to the AWS APIs on our behalf. It will need to connect to our VPC, provision some resources, virtual machines, etc., pull the container images from the ECR, and so on. So we're going to create a role that will permit virtual machines provisioned by Fargate to do all this stuff. So let's go to IAM service first and create that role. And that role is going to be attached to EKS because all these components like node group, Fargate, etc., they're part of the EKS service. They're connected to EKS. So we are going to choose EKS here. And down here, you see, again, the list of different use cases. We have created already 2 of them. We have created a role for EKS cluster use case as well as node group. Now we can create a role for Fargate pod. And here you see the description. It allows access to other AWS services so that Fargate can schedule pods on the new VMs. So I'm going to select this one here and go to next permissions. And we're going to get a pre-selected policy here. This is EKS Fargate pod execution role policy. Again, if we expand it, we should see the permissions that this role will get through the policy. So Elastic Container Registry read permission. So basically it will be able to get images from ECR. And let's go to review, and we can give the role a name. Let's call it EKS Fargate role. And right here we have the service that the role is getting attached to, and we have the policy. So I'm going to create the role. And now that we have the role, we can actually go and create a Fargate profile. So what is a Fargate profile? The way it works is essentially Fargate profile creates a rule. So whenever we tell Fargate, here is a pod configuration or deployment YAML configuration, Fargate, based on the profile rules and what we defined here, can decide whether that pod should be scheduled through Fargate. As I said, we can use both node groups or EC2 instances in Fargate for the same cluster. So Fargate profile lets us define the criteria to decide how the new pod should be scheduled. And we're going to see how we define these criteria or these rules. First of all, let's assign Fargate profile a name. Let's call it dev profile. And this is the role selection for the Fargate role. And again, since AWS automatically finds the role that is suitable for this profile, it automatically suggests that one from the list. If we didn't have any suitable role, then it would just be empty because all the other existing roles are not suitable. So we're going to select this one here. And here we have the subnets which belong to the VPC we defined for our worker nodes. Now you may be asking, if Fargate is going to provision virtual machines on AWS managed account and we're not going to see any EC2 instances or virtual machines on our account, why do we need to provide our own VPC? Nothing is going to run in our VPC or subnet, right? The reason is because the pods that will get scheduled using Fargate will get an IP address, and that IP address will be actually from the range that our subnets have. So our VPC and subnet networking information will actually be used to schedule pods, even though they are going to be scheduled on a completely different VPC in the AWS managed account. So what AWS has automatically done here is that they actually removed the public subnets because Fargate will need to create the pods only in the private subnet. As we said previously, we have created a public subnet and private subnet in two different AZs so that external components like external load balancers belonging to AWS can be created in public subnets. And internal components like pods can be created in private subnets. So that's why they've actually removed the public subnets from here and just left the private ones. So we have the selection here and we can go to the next page. And this is the configuration of the Fargate rules, so to say, that I mentioned previously. So basically we need some type of selectors that will tell Fargate this pod is meant to be scheduled by Fargate. So let's actually go back to our Kubernetes YAML configuration and look at a deployment. This is a simple Nginx deployment that we used previously, and this is the pod template. And in this configuration file, we have different attributes that we assign to pod, right? And some of these attributes are, for example, which namespace the pod is going to run in, right? By default, if we don't specify anything, it's obviously the default namespace. However, in every deployment, we can specify that this pod is going to run in a namespace called dev, for example. And using this information, we can actually create a Fargate rule or Fargate profile that defines a namespace selector for the pods. So basically this means that if I type in namespace dev here, Fargate will read the pod configuration when I try to deploy it using kubectl apply, and it will check whether the pod configuration, or in this case deployment configuration, has namespace dev defined. If it does, then Fargate will decide this is the pod I need to schedule through Fargate. If not, it will be handed over, so to say, to be scheduled on one of the EC2 instances in our node group. So for example, if I didn't have a namespace here, which would be namespace default, or if I had another namespace, basically it will not be scheduled using this Fargate profile. So let's actually change it to dev. Now, another thing that we can also configure in a Fargate profile is label selectors. So right here, below the namespace, we also have something called match labels, which is empty right now. So if we go back to our deployment configuration, we also see that components in Kubernetes, pods, as well as services, etc., they have labels, right? Just like you see here, this pod here has label app nginx. So I can add arbitrary key value pairs here as labels, right? I can do profile Fargate, or I can do environment development, and so on. And I can also add multiple labels. So basically this is a place where I can arbitrarily define labels. These are kind of like the tags that you see in AWS, right? Every component that we create, we can actually create tags for them to add some key value pair as some additional information or data. So this is a similar concept here. So here we can actually add profile Fargate as a test. And basically this is selector for labels defined here. And now we can actually take that profile Fargate label and add it here. So we have key, profile, and value Fargate. And as you see, we can add 4 more labels to match different pods, obviously, as well as additional namespaces. So combination of namespaces and labels is basically how we can configure a Fargate profile that will match our pods, right? So we can look at our pod definition and then we can create a Fargate profile that will match that pod definition. I will give you an example use case for this. Let's say we have an EKS cluster that has node group and has Fargate profile. We could decide to split a dev and test environment inside the same EKS cluster. So we can create the test environment, let's say in the node group, and the dev environment in Fargate. So in this case, we could actually tag pods with the respective selectors or labels or namespaces, for example, so that pods that have namespace dev, for example, will all be scheduled on Fargate, and the ones that have some other namespace, basically not namespace dev, will be scheduled on node group. Another use case is, since Fargate has limitations in terms of what Kubernetes components it can deploy. For example, we cannot deploy daemon sets for logging, like FluentD, for example, or stateful applications like databases through Fargate, as you've learned before. So in this case, it might make sense to have node group or EC2 instances for stateful applications and daemon sets, etc., and then use Fargate profile for stateless applications. So there are different use cases for having this mixed setup. So with this configuration, we can actually go to the next page, which is the review page, we have basically just defined the role, subnets, and some rules. We have a namespace selector for dev and label matching for profile Fargate. And let's create our Fargate profile. We see status profile creating, and this may actually take a couple of minutes. And as you see, the profile is already active, so we can now deploy our first pod through Fargate. So right here in compute of the EKS cluster, you see we have both EKS node group and Fargate profile. So now what we are going to do is basically apply this nginx config that will create deployment and the pod. So I'm going to go back to command line. And let's actually check our pods. We have one nginx pod running on our EC2 instances, and we have our EC2 instances running, which are managed by our node group. So this is our current status. We have not created any pods through Fargate yet, and we just have the default namespace in addition to the control plane process namespaces. So first thing is we're going to create a namespace called dev, because the namespace must exist before we create, or we want to create a pod in that namespace. So I'm just going to create it here. And as the next step, we're going to apply this nginx config file. So I'm going to execute and deployment and pod created. So now we're going to see some interesting outputs here. First of all, let's check that our pod is running. So let's do kubectl get pods, of course in the namespace of dev. The status is pending, so I'm going to run the command with the W flag at the end, or wait flag, which will track the status changes in the pod until it is ready. And there you go, this is our nginx pod running in dev namespace. And now we're going to do get nodes. And here you see these are our EC2 instances. We also have these instances running in our AWS account. If we go back to the EC2 service in the AWS UI, we can see them running here. And these are the instances that we have configured in the EKS node group. So these are actually the instances which are running. Let's refresh it just to be sure. And the other node that you see here has a Fargate IP prefix. And the IP address is part of the same VPC IP range that we created. So the IP addresses that all of our nodes get have the same IP address range, which comes from the VPC IP address range. As you see here, this part is the same. So even though these nodes are the EC2 instances running on our AWS account, as you just saw, and the Fargate is basically a virtual machine provisioned outside our account, we don't see that. We're not going to see that. We don't even have access to it. It's hidden away because it's completely managed by AWS. They are still in the same VPC, right? So that they can communicate with each other. And now, if I remove that namespace or change it to default again, which is the default namespace, and let's actually change it to 2 replicas. And let's actually change the name here because we already have a deployment with name nginx in default namespace. So let's call it nginx test, doesn't really matter. And apply. Let's do kubectl get pods. We're in the default namespace. Here you see these 2 pods got created, and these are all running on the EC2 instance. Let's do a wide. And right here, you see the 2 different node IP addresses, right? So the first one right here, and then these 2, which are the same. If we go back to our instances, we can see that these are the IP addresses of 2 of the instances in our node group. So we have one IP address associated to this instance here, 10.197, and then another one here, 236.183. So we know that these pods are running on our instances from our node group. And if I go back here and do, let's say, nginx dev and namespace dev and 2 replicas again. So now this will obviously match the Fargate profile we defined in our cluster, because namespace is again dev and we have this profile, Fargate label. So I'm gonna do kubectl apply again. And let's check the pods again. And here you see the pods are pending because every time a new pod needs to get scheduled, obviously Fargate needs to provision a VM, right? So you have to imagine that each pod is running in its own virtual machine. In the EC2 instance case, basically we have multiple pods which are running on the same server. That's why you see pending, because the virtual machine is getting provisioned. And the pods are still pending, so I'm gonna wait a few seconds and try again. It shouldn't take very long. And now they are both running, so now let's do get pods -o wide again. And here you see all of them are running on different Fargate nodes. So we have Fargate IP as a prefix, and you have IP addresses from the same IP address range. However, these are different IP addresses, so each one is running on a separate VM with its own separate IP address. And if I go back to my AWS EC2 instances view and refresh, we now actually have 2 EC2 instances running, as our autoscaling group has decreased the number of instances here, which we defined by the minimum number value in the configuration. And all these new services are basically running on another account. So now if we do kubectl get nodes, there you go, we have our EC2 instances right here, and we have Fargate nodes for each pod. So if we have 10 pods running on Fargate, we're gonna have 10 Fargate nodes. So that's how Fargate profiles and launching pods through Fargate work compared to node group. And obviously you can also create multiple Fargate profiles, just like you would be able to create multiple node groups. So each Fargate profile can match a different namespace, maybe different labels. So this way you can separate or automatically basically distribute your pod load based on different Fargate profiles. Now let's say we are actually done with the cluster. We don't want to use it anymore and we want to destroy the whole thing. And of course we want to clean up all the resources that we have created, right? So here we have the node group, Fargate profile, both part of EKS cluster. So before we can actually delete the cluster, we need to remove node groups and Fargate profiles, because otherwise we're gonna get error that node group is attached to it. So we can delete them both. We just get some information here. It's deleting. We can also delete Fargate profile. And now both node group and Fargate profile are deleted. We can go ahead and delete the cluster. And this will take some time because just like with provisioning, a bunch of resources are getting created in the background, again in AWS managed account. So we don't see all these resources. So now all of them get destroyed and deleted in order to clean up the whole EKS cluster. So our test cluster also got deleted. And now we can clean up the rest of the resources. First of all, we have created a bunch of roles for the cluster. So the EKS cluster, node group, and then for Fargate. So we have these 3 roles that we can all just remove. if I refresh the instances here, I should see the instances managed by the node group are terminated once we delete the node group. And as the node group is also managing the EC2 instances and their life cycles, they are terminated automatically. So we didn't have to shut this down separately. The node group actually handles that. And finally, if we go back to our CloudFormation stack, we can remove the last parts of our configuration here. So this is the stack here. If we just select the stack and choose delete, CloudFormation will remove the VPCs, subnets, and everything else it created from our AWS account.